Hello everybody, welcome to my YouTube channel Precision Manufacturing System. I'm back with another interesting video regarding buckling analysis of composite cylindrical sheet with a central hole. Please subscribe to my YouTube channel and hit the like button if you found this video is interesting and useful for you guys, and stay with me until end of this video. So let's get started and start the tutorial. For buckling the composite panel, first of all we need to modeling a panel. For that's why we should use create parts and deformable. Our panel is a shell and revolution. It is note that please note that the units which I am using for this simulation are based on inch, and all dimension is are based on inch or pound. If I apply any force, the force is based on the units of the force is based on actually pound. So we need just line. Okay. (14" and angle 55.6. Okay, this is our panel, a cylindrical panel. To create a hole at the center of this panel, we need to create actually bottom panel. For that's why we need to create a panel. So we use datum, select plane and 3 points. By clicking 3 points, a plane is created, and then create select the create cut extrude, select the created panel plane, and then select edge of the panel, and then to actually create and model a hole, we need to, since the panel has a curvature, we cannot draw a circle at the middle of the actually plane. For that's why we need to first we have to project the edges of the panel, and then we can draw a circle. Okay, and then we draw a circle in the middle of the center of the panel. Then the dimension of the circle is the radius is 1. Then after that we have to delete the projection line. Oops. Okay, and okay, it's done. Now our panel is ready, and we can continue by property. as you guys maybe know, for creating a section and assigning the material property composite material property to a panel or tube, we have two choices. And the first one is actually layup, using the layup method, and the second one is using the stiffness matrix. In this tutorial, I am going to use the second method, namely a stiffness matrix, and I will promise you guys I will create another video and show you guys how you can define the material property, composite material property, by layup method. Okay, let's continue. For defining the stiffness matrix, we have to click on actually create section, and then general shell stiffness, and continue. So the number we have to put here, then 251 367 7239 0 0 269 239 0 492.719 0 0 191.50 and 50 0 0 0 80.9245 80.9245 203.602. Okay, and then we have to assign this material to our panel. Okay, and then we continue with assembly. We import our model in assembly and click independent, since we want to mesh based on instance, not based on part. Okay, here we have to create some partition on our panel. For that's why we need some actually sorry, okay, we need to some points. For that's why we have to create a point here, and then we can use this method to create a panel datum, and then partition our parts. Okay, and then again use 3-point method to create a datum horizontally, and then partition the panel, use the panel datum created. Okay, for applying actually boundary condition, we need some sets, and here it's better to define those sets. For defining sets, we can go tools and set create, and then named top, and select the top edge of our panel, and then OK. Again, another sets we need for bottom edge, and by clicking holding the shift key, we can choose both edge simultaneously, and then the last one is side edges. Okay, it's okay, and here we need to define our steps and the analysis. The procedure type, we should change this one because we want to use buckle methods, and choose subspace, and number of eigenvalues. We're going to put 10 and 15 here and 20 here. Okay, select stress, and here displacement as a field output, and then continue with interaction. Since we need some actually node sets for applying some equation constraint actually, so we need to first mesh our panel. Okay, let's continue with actually with meshing structure. Okay, and then standard linear, and membrane strain, put select the small for this simulation, and here shell. Okay, and mesh the panel. Okay, and then come back to interaction module and create set for defining equation constraint. Selected nodes, all nodes of the top edge except the central node. I mean this node. This is for the first constraint, and again we need another set for the central node to apply the concentrate force. Okay, and then here we define the constraint equation as a coefficient 1 for equation set 1, and degree of freedom put 2, and -1 for equation number 2, and degree of freedom is 2. Okay, now we have to apply our boundary condition and concentrating force. Here we have to select concentrating force, and from sets select the equation set 2, which is related to the a central node, this node, and put 1000 pound force, and for edge we need to fix the bottom edge, and for actually we have to rename it this button. Okay, and for top edges we have to create a boundary condition, and just it should be free in U direction. And for sides edge we just constrain the U1 and U3. Okay, that's it. And we already done the mesh and create, just remain part is the create a job, and okay, then submit. There we go, it's done. Our simulation complete successfully, and the result is, you can see our result from here. This is the mode 1. As you can see, the panel, we have deformation in panel, and this is the mode 2, and you can see all modes and see the deformation on panel, composite panel. Actually, you can change the number of mode as you wish, and or increase it. And also, if you need a pass to see to plot the curve, you have to use pass and click here and choose these nodes, to make a pass, and then by these actually yes, from here we have to select displacement and magnitude, and then plots. And you can see the plot displacement plot along the path, and just this. Next time I will prepare another tutorial about how you can define material property for composite panel based on layup method. Thank you for watching this video and staying with me until this end of this video. Please subscribe to my channel and hit the like button. Thank you so much. Don't forget to subscribe to my YouTube channel. Bye bye.